good day. I am Rachel Mason, and these are my colleagues.
Tyrese Wilson, Sylvania Wood,
and Cleveland Lewis.
And we are Group P, who are a team of young engineers. We have been hired by an exclusive health club and gym which produces elaborate smoothies for their clients. We are required to design a unique citrus juicer that will enhance the experience.
Each member contributed to different key attributes towards the success of the group. I contributed design skills and creativity.
I contributed leadership skills and analytical skills.
I contributed innovation and logical thinking.
I contributed technical writing and critical thinking. Each member was tasked with different sections of the project as well. I was tasked with the background research and the morphological chart.
I was tasked with the metrics table, pairwise comparison chart, and PowerPoint editing.
I was tasked with the literature review, problem statement, and aim.
I was tasked with the user/client requirements, design specifications, and the key attributes. We all contributed towards the SolidWorks design, concept generation, and we each did a patent review. Welcome to our selection.
The device aims to ensure the juice has high quality, which will enhance the smoothie. To create this device, our research started with a background on citrus and citrus juicer.
Citrus fruits are characterized by their thick, leathery rind, white pit that encases juicy segments and juicy pulp inside. Different types of citruses range from oranges to limes to grapefruit, with each category having subcategories. Citrus production has become large-scale in warm areas such as Belize and Jamaica. Citrus juicing is the extraction of juice from citrus fruit. Citrus fruits have unique properties that require a special juicer to obtain this juice. There are two methods: manually, which requires human effort, and automatically, which requires little to no human effort. Health benefits of citrus fruits include excellent source of vitamin C, good source of fiber, and they are good for weight loss. It is safely assumed that the health club and the gym receive the citrus fruit from local suppliers with no chemicals present. However, the fruits need to be tested post-harvest for the quality. This can be done by examining either the exterior, which will be texture, weight, color, and firmness, or interior of the fruit, which can be done manually or automatically and is tested for diseases, pH level, sugar content, etc.
Smoothies can include a mix of healthy protein and carbohydrates. Therefore, the product statement states that smoothies are an ideal way to ingest both pre- and post-workout, as it is flavorful and portable. Therefore, citrus fruits should be tested to ensure the quality is high before being placed into the smoothies. An exclusive health club and gym requires citrus juicer that will enhance the experience for their clients. The project aims to design a unique citrus juicer for an exclusive health club and gym that enhances the experience for their clients by producing elaborate smoothies.
The objectives were to conduct relevant literature and patent reviews to help achieve the aim, to determine client/user requirements and key attributes and incorporate them into the design, to create 3 conceptual designs consisting of key attributes and selecting the most appropriate design that can best achieve the aim, to select a final design and make necessary improvements, to create a prototype from the final design to show how the machine would function or look in reality.
Citrus is a term referred to as a classification of flowering plants in the rue family. The name citrus was derived from the Greek word cedar because of comparable smells. The majority of citrus fruits originate from a small group of plants that are derived from 4 species in Southeast Asia. Several citrus fruits are combinations between more common selections. Figures 7 to 12 showing hybrid citrus fruits. Before citrus juicers were invented, crushers were used to extract juice from the fruits, and this was a tiresome process. Hence, all the rind from the citrus would have been included in the juice. Juicers then became mechanical with the help of Dr. Norman Walker. His machine functioned using a simple mechanics, but it was bulky and difficult to use. Also, the rind was included in the juice, which gave it a bitter taste. Therefore, persons started to realize citrus fruits needed its own juicer technique from regular fruits in 1945. Citrus juicers can either be manual or automatic. For the manual juicer, some advantages are it's easier to clean, silent operation during juicing, and there are no high-speed rotations involved, so no oxidization, thus preserving the enzymes and nutrients of the juice. Some disadvantages are it's time-consuming, more effort is required, and limited types of manual juicers. For the automatic juicer, some advantages are it's more efficient, the cone for juicing can be changed depending on the size of the citrus that needs to be juiced. Some disadvantages are Some motors can be underpowered and it's expensive.
For patent review 1, citrus fruits are placed in the hooper 28 and are rolled around the wall, and the fruit enters a cylindrical passageway. At the top of the passageway, a fruit is allowed to pass to a pivoted fruit pusher 86, receives the fruit and is pushed onto a knife 34. After cutting, the halves are rotated and the fruit halves engage the pads 36 so it would be level with the cup assembly, with the use of the slanted knives, which tends to screw the halves tightly into position in the cups during processing. Each cup receives a ejector plow which presses off the rinds into the chute 44 and allows the juice to fall into the juice bowl 40 by the juice sprout 42. A debris exit chute 46 is above the shoulder of the juice sprout, which has a screen 66 which prevents seeds and pulp from entering the juice bowl. Disadvantages: this device can only juice one fruit at a time.
Patent Review 2. The machine works by feeding it with the citrus fruit into the curved shoes label 1, which goes towards the angled knife label 2. It is then forced across this knife to be cut in half by a mechanism that ensures that the fruit is directed properly towards the knife to be cut. The knife is angled in order to prevent friction and crushing of the citrus fruit being halved, especially when the citrus fruit used is soft. It is moved towards the surfaces of the cam pedestal label 3. The cam pedestal is also angled accordingly to help with the placement of the cut halves onto the rubber sheet. The cam pedestal then expresses the juice into the cones labeled 10. The only disadvantage to this design is that the discarding of the rind seeds are not done automatically as well.
Patent Review 3. This invention consists of a citrus juicer that has an electric motor enclosed by a base. The motor drives a pair of upstanding spindles containing the juicing cones. The juicing cones is located above the container for the collection of juice. The container is readily removable to allow for the ease of cleaning. A lid is arranged to extend over the juicing cones and the container. The lid is there to apply pressure onto the halved citrus fruit in order to allow it for juicing. The lid is molded out of plastic in a single piece to allow for simultaneous juicing of the halves of the citrus fruit.
The automatic citrus fruit juicer has a fixed frame with an upper platform 2 and a lower platform 3. A first drum 5 with a vertical axis is mounted and actuated between the platforms and is crossed by holes for the passage of the fruit juice. A second drum 10 with a vertical axis is rotatable eccentrically outside the first drum 5 and is provided with lateral pressing means 11A and 11B for pressing its inner surface towards the outer surface of the first drum at a citrus fruit squashing region. A unit 17 for cutting fruits F into two halves is mounted above the drums at the opening of the platform, provided to allow the fruits F to drop between the drums 5 and 10, so that the cut surfaces of the citrus fruit rest against the surface of the first drum. The lower platform is provided with a hole 28 for the exit of the fruit juice, with a chute 29 for removing the peels of the squashed fruit halves.
The client requirements are as follows. The device should test the citrus for suitability internal testing, not injure operators during operation, discard unwanted citrus which is deemed bad and all waste. The user requirements are: the device should cut and juice the respective citrus, operate easily. With the client requirements and constraints taken into full consideration, our team has designed 3 concepts. Each design has the following features, which are the design specifications. The machine should include methods to ensure high quality juice is delivered, an effective juicing mechanism, a filtration system, ability to remove the remains of the citrus fruits. The problem definition clarified the objectives to the client/user requirements which were previously mentioned. The key attributes for our design were found to be stability, durability, efficiency, safe to operate, quality of juice.
The functional decomposition black box, transparent box, and function means tree are sections which were all taken into consideration in the design process. The black box is the first part of the design process. It is a representation of the input, function, and output of the device. For this black box, the inputs are citrus fruits, electricity, and instructions. The function is the citrus juicer extracting juice from the citrus fruits. The output is waste materials, vibrations, song, heat, and citrus fruits. A table format of the black box was also done. The transparent box shows a little bit more detail in the device and how it would be carried out. The citrus fruit enters the device where it is tested with sensors, and if it is of a certain quality, it enters the juicer, else it goes into a bin. The fruit is secured and sliced in half. The citrus halves are pressed to extract the juice, which is filtered using a strainer and stored by collecting it in a container. The sub-function and means were also done in a table format. The process of extracting juice from the citrus fruit is laid out in this flow diagram. This chart shows the different steps that will occur for the juicing process. Using electrical energy, the citrus fruit is tested in its respective manner. If it is unsatisfactory, the fruit is removed. Once it passes that stage, the fruit is secured. The electrical energy is now transformed into mechanical energy to cut the fruit into halves and extract the juice. All waste materials are removed at this stage.
Functional ministry. Citrus fruits are what is needed for the entire process. Citrus juicing becomes our main function. To achieve this function, we have sub-functions, which is testing, securing, cutting, extracting, and filtering. Squeezing, clamping, and pressing are some of the means to achieve the sub-functions. As shown in the objective tree chart, these objectives were considered to design our unique citrus juicer.
The metric table is being ranked from 1 to 3, 1 being the least favorable to occur, while 3 being the most favorable to occur. For example, for durability, the least to occur is for the device have a lifespan of some months, so it is given a 1, whereas according to the objectives, the most favorable to occur is a lifespan of 3+ years, so it is given a 3.
The pairwise comparison chart ranks the key attributes and assigns an equivalent relative weighting. As you can see from the chart, the quality of juice has the highest weighting, therefore it is the most important attribute. The morphological chart. This shows various ways of accomplishing each of the sub-functions highlighted with the addition of the power supply. For example, to turn on a system, it has 3 options, which are to use a switch, press a button, or use a remote. When making the conceptual designs, the designer chose the best option which was most suitable. Using the morphological chart, 3 concepts were designed. All the 3 concepts were designed to have a suitable electrical power source and a fail switch emergency stop.
Concept 1. It uses electrical energy. Citrus fruit is placed onto the conveyor belt and encounters the first testing stage. The UV ray emitter 7 is connected to a control system that interacts with the essential oils in respective citruses. If the fruit emits fluorescence, the control system will now switch the tracks of the conveyor and the decayed fruit will be thrown away into the bin 1. The citrus fruit is passed through another set of visible light emitters. This is connected to another control system where spectral images are detected. Spectral imaging tests the different contents of sugar in the fruits. If sugar content is low, the fruit will be removed. It enters the machine 4 and is secured by clamping it. It is cut in half by a motorized blade and 2 adjustable claws grab the fruit. Those 2 halves are juiced by the juicer's 8 and the waste is discarded into the bin. The juice is filtered by the double filtration system and it is collected at the bottom to be used later.
Concept 2 also uses electrical energy. The citrus fruit is stored in a basket. There is a hole at the bottom of the basket and at the top of the machine to allow the flow of the citrus fruits to begin the process. The piston allows one citrus to pass through and to be tested with probes. If the machine finds the citrus is bad, the side piston pushes that fruit into the bin. The back piston then pushes that fruit onto the blade to be sliced. This process is repeated. The halves of the citrus slide down on either side on top of the resting plate. The cup pushes the resting plate with the citrus fruit downwards into the container, where the citrus makes contact with the rotating extraction cone where juice is extracted. The juice waste flows onto the filter system, which is a conveyor belt. The waste is exposed into the bin and the juice flows into the user's cup. The cup and the resting plate with the citrus then returns to starting level. Subsequently, the waste disposer rotates and pushes the citrus into the bin.
Concept 3. The fruits are secured in a basket 7 located at the top of the device. It begins the process by rolling into a juicer via a guided slide 11. The fruit is met by a barrier 2 where it undergoes quality testing with the use of 2 probes 8, which puncture the fruit and test the pH and bacteria using sensors. If the fruit is good, it then goes to be juiced. If not, it is disposed by a rod that will push it directly into the bin from a hole located at the side of the device. If a spoiled fruit is encountered, the probes will change automatically so that there is no contamination of the other fruits. The juicing process consists of 2 circular rollers 5, with holes to allow the fruit to fit. The barrier then gives way and the fruit falls into the roller, where it is sliced by a knife, lining it up perfectly with the ball rollers.
After juicing, the rind is discarded into the bin 7 and the juice is filtered into a glass container 3.
Now we have a table of conceptual designs. This concept rating table compares how the actions are accomplished in the different concepts, previously shown where 1 is the worst and 3 is the best. A Pew chart was also constructed. Each design concept was evaluated using the key attributes by using the data from the rating of the concepts for the raw scores and multiplies it by the relative weighting to obtain a weighted score. The total weighted score was then found and compared. Concept 2 had the greatest score with a value of 2.48, followed by Concept 3, 2.2, and Concept 1, 2.08.
Now we have arrived at our final concept. The second concept was enhanced for the final concept. The conveyor belt was added to allow for extra testing for diseases and the sugar content. The fruit would be manually placed onto the conveyor and it will be passed through 2 lights, one being a UV light which would test the fruit for any diseases and the other being a visible light that would test the sugar content of the fruit. If it fails the test, it would be removed by a skilled worker. However, if it passes, it will go into the basket and it is tested further for its pH level using 2 probes, which will inject it and collect a sample. Once the fruit is deemed satisfactory, the fruit will be juiced. We have reached the end of our presentation. Here is a list of our references. Thank you for your time.